Okay. In this question, the question is to evaluate this integral, but it's not polar in terms, it's not x squared plus y squared. It's x squared, y squared, and z squared. So you get into 3D polar. You can replace x squared, y squared, z squared by p squared, and the rule for dv becomes p squared sine of phi, or we can call it angle 1, dp, d angle 1, and d angle 2. Okay, so to do this, first of all, we need to have the limits of integration. This we can replace by p squared, and it's still raised to 3 over 2. And dv, we can put p squared sine of angle 1 dp d angle 1 d angle 2. We need the limits for p. Since they tell you that this is less than or equal 1, they tell you that you can only go from minimum 0 to 1. Now, for angle 2, there's no certain way to do it. You have to be able to draw a 3D, and I know a lot of people have a problem with this, but this works most of the time. It's the cosine inverse of 1 over radius. And since your radius is 1, so it would be cosine inverse of 1 over 1, 1, and that would be negative pi, and this would be pi. So this will give you eventually pi. So I know that my angle is from 0 to pi. This angle 2 is very straightforward. It's just a complete circle. So now we try and integrate this. You'll notice that when you have something squared and raised to another exponent, when you raise to multiple exponents, you multiply the exponents. It would be 3 over 2 times 2. Eventually, that becomes p cubed. So when you raise to multiple exponents, you multiply, so it becomes p cubed. So we're going to have we're going to have this to integrate. The way to integrate this, and since we're integrating dp, so sine angle 1 is constant, I'm going to use u sub. U being p cubed, du would be 3p squared dp. Get rid of the number, du over 3. So I'm integrating e to the u, and p squared dp is du over 3. So the answer is 3 e to the u, or 1/3 e to the p cubed. So now I'm going to erase some of this. I know that I'm integrating 0 to pi, 0 pi, 0, 1, but I'm going to plug now. And the result of the integration was 1/3 e to the p cubed. Now we're going to plug 1 and 0. You still have sine angle 1, and you still have d angle and d angle 2. Plug 1, you have 3 e to the 1 plug 0, e to the 0 is 1, so 1/3. So the answer would be e minus 1 over 3, basically. So it would be e minus 1 over 3 sine angle 1, d angle 1, d theta, and you still have 0 pi, 0, 2 pi. Okay. Integral of sine is cosine, so you have e minus 1 over 3 cosine, but negative. And I'm going to plug pi and 0. And I'm still integrating from 0 to pi d theta. Plug pi, cosine of pi is -1, and a negative becomes positive. Minus, minus, or plus. Cosine of 0 is 1, so it becomes e minus 1 over 3 d theta, and 0 to pi. When you add these two, so you have a constant, I can bring it outside, common denominator 3, e and e, 2e, minus 1, minus 1, minus 2, that's a constant. And then you're integrating theta, that would be, oh sorry, d theta would be theta, and 2 pi and 0. Then you have 2e minus 2 over 3, plug 2 pi, plug 0. So the answer would be 2e minus 2 over 3 times 2 pi. And you can just leave it as it is, expand it, but that's the final answer. I'm also going to do the question from 5b. So the question was, just integrate dv, and they tell you in the question, that's 5b, that above this, inside z squared, y squared, z squared 2. And since we know that this is p squared, so p squared is 2. If p squared is 2, so the limits dv, we put p squared so p would, the limits for p would be square root of this, so 0 to root 2. Now, the angle here is the problem, and I told you it's either you can visualize it or sketch it, or you can try this concept, which is cosine inverse 1 over radius, which is cosine inverse 1 over root 2 pi over 4. So that would be 0 pi over 4. And for the angle 2, it's just a complete circle. Okay, so you integrate with respect to p, 3 over 3. And you still have d phi and d theta. And you still need 0 pi over 4 and 0 to pi. And we need to plug root 2 and 0. I'm going to erase some of this. Root 2 cubed would be root 2 times root 2 times root 2, so that's 2 root 2 over 3 sine. Angle minus 0, 0 will cancel. So d angle 1, d theta, and we're still doing 0 pi over 4 and 0, 2 pi. Integration of sine would be minus cosine d theta, and we need to plug 0 and pi over 4. And remember, you're still integrating 0 to 2 pi. Plug pi over 4, cosine of pi over 4 is 1 over root 2, so you have minus 2 root 2 over 3, 1 over root 2. Minus minus becomes plus, cosine of 0 is 1. D theta. 0 to 2 pi. Cancels, cancels. So you're integrating a constant. The constant is denominator 3 minus 2, 2 root 2. You're integrating this, and that would be theta, 2 pi, and 0. You plug the 2 pi, you plug the 0, eventually you get 2 plus 2 root 2 over 3 times 2 pi. This is the final answer. Again, this is one of the hard worksheets, so that's why I wanted to do both of them. So make sure that you understand everything and keep the hard work. Good luck.